an estimate is safe. And when an estimate is safe, then a validator can propose it safely. And so that's kind of the rough idea. There's a lot more details that I'm kind of eliding, partly because we have so much to get through, but also partly because I'm driving. But so Vlad has done, a very, very professional job. It's kind of the way mathematics is traditionally done. So first he attempted this algorithm to provide a consensus on just a single bit. And then having convinced himself and actually produced a proof and an algorithm for getting consensus on a single bit, he moved on to considering consensus on a richer data structure. So he looked at two different data structures. One was a ranked voting, and the other was a blockchain. And in those cases, he's got simulations, which are very, very convincing, promising. And now what he wanted to do was to look at a data structure. Sorry, I need to check the map here. Yeah, he wanted to look at a data structure that was less blockchain-like because of some of the bad properties of blockchains, and more directly like a VM, whether it's the Ethereum VM or any other kind of VM. And so we were talking about that, and I suggested, well, why don't we just look at an arbitrary term rewrite system rather than just a VM? So we kind of worked at that level of generality and believe that there's still a lot of work to be done. I want to be super, super clear about that. There's still a lot of work to be done, but it looks quite promising that the algorithm extends to an arbitrary term rewrite system. Now, the reason this is interesting is because you could, here's the kind of thing you could imagine. Let me take a step back and talk a little bit about the scope of term rewrite systems. So every programming language that you know about, whether you're talking JavaScript or Java, whether you're talking C# or F# or OCaml or Haskell, these are all representable in terms of term rewrite systems. So when we talk about finding a consensus algorithm, a replication algorithm for a general term rewrite system, what we've just said is that we could provide consensus for the execution of any programming language, any modern programming language. And by extension, any VM, whether it's the Java VM or the Ethereum virtual machine, any of those are now something that you could provide consensus over. So what's sorry, I just hit a road closed on the Google Maps, so that's kind of interesting. So what this means is that you could potentially, if you had a means to write down a specification of any of these languages as a term rewrite system, then you could potentially press a button and out would pop a distributed implementation of this, a decentralized distributed implementation of this. So that's pretty remarkable. And now, if folks remember from last week, we've been talking with the K-framework people, Grigori Rostu's people, about using K-framework, which is exactly a specification system for writing down term rewrite style systems. So that so you could imagine that there could be a K framework plus plus, right? A souped up K framework in which you press a button and out pops a decentralized version of that language or VM or what have you, which means that the platform part of this decentralization movement becomes completely commoditized. There is zero value in the platform. Again, let me repeat that. There is zero value in the platform because anybody within, I would say, as early as 2 years and as far out as about 7 years, it will be possible to press a button and generate a platform of the level of far beyond the level of capability and functionality of Ethereum today. So that's why there needs to be significant focus on application, because what makes these networks viable is the communities around them. It's the people and the value that they bring in terms of how they relate to each other that makes this work. So that's one of the reasons why RChain is structured in the way that we're structured. The co-op is there to help provide these kinds of community level algorithms, but stuff that ought to be in the public. But at the end of the day, the real value prop is going to be in the applications, and at least with respect to RChain, that's RChain Holdings Company. So that's I'm trying to place these technical results in a wider sort of business and social context, so that people understand a lot of the choices that we've made and why we made them. So I've known for quite some time that we would get to this place where the platform part effectively becomes commoditized, and that the real value is going to be in the applications. That doesn't mean that there isn't significant effort in maintaining a network around a particular platform that has been instantiated. But the reality is that the platform part of the technology is going to become completely commoditized. So I'm going to stop there before we move on to the other updates and sort of check in with people and make sure that they've understood, if they have any questions about this, that sort of thing. Yeah, thoughts, comments?
Yeah, I just wanted to.
That was great. The from the Casper meeting, it wasn't completely clear, but this is a very dramatic moment in that our mission in terms of our platform is under examination.
Yeah, I just wanted to say, if anyone wanted a more detailed insight into the Casper algorithm, especially just if they want like a re-explanation of Vlad's, binary consensus, I'm always down for that. I think Vlad has taught me enough to relay that onto people. So, yeah, maybe, I don't know, actually, Jim,
Vlad mentioned to me he was giving a presentation at 5:30 today. Is that going to be recorded? Do you know?
I don't know.
Okay, sorry.
So maybe at the noob study group tomorrow, you could give a little presentation. That would be cool.
Yeah, I think that works.
What kind of presentation was that? You were talking about 5:30.
I think that's at MIT. At MIT, they have an economics and
So he's not in
economics.
Seattle anymore? Okay.
No. No, he's in Boston right now. So that's that part of the part of the set of updates. I also want to talk about some other technical updates that are related to what we've been doing with Ladle. But before we get there, I want to kind of turn it over to Kent and Glenn and see if they can talk a little bit about the work that Kent and Glenn and Joe and Alex and I have all been doing. So if Kent and Glenn and Joe can speak to the work that we've been doing, and in particular, I believe that we have some side-by-side code that we can show. That might be useful for people to take a look at.
Glenn, Joe, I have the code on IntelliJ if I can screen share. Does that work for you guys?
Yeah, please.
Okay. So, does everyone see that? Does everyone see that?
I got it.
Okay. So on the left side, we have the ERC token that's it's on the wiki. I put the link here, written in Solidity. And on the right side, we have the approximate equivalent of that in Rolang that we've been working on the past few days. And I guess just quickly going over the token contract, we have a token contract. It requires the message sender, which is the creator of this token contract, and then the total supply of it. And that gets passed down. Ignore all these steps for now, but it gets passed down such as the total supply gets sent to the owner, and this balance is it's a map that stores all the mappings between addresses, or I guess channels, and integers, which is the amount of the token they own.
What does the double exclamation mark mean?
Oh yeah.
Oh, we're going to get to that. There are a couple of nice language feature discussions that we are going to have.
Okay, so yeah, if we're going to skip over that now, then we can get into the functions, which essentially these are just the equivalents of the functions in the ERC20 Solidity code. But balance of the way you read this would be, if you send in the channel of whatever owner you're trying to query the balance for, on the return channel, it just returns that balance. This star notation is also another language feature that we could discuss later, but for now you can just ignore that too. This def transfer, this is kind of the standard way to send over the tokens, and it implies the message sender is also the person who you're sending from, and then the to here is the person who you're sending to. And we have a bunch of conditional statements that we need to check. This is the amount has to be greater than 0. This is an overflow check, and this is just the fact that the sender has enough to send.
It's probably good right now to mention actually what the star notation means. So if we have a channel, say for example, balance of sender, then the channel balance of sender is where we actually store the integer that represents that balance. So Without the asterisk, without the star, we can think of that as just a channel. With the asterisk, we can think of that as an eval. So it says, get me the value that is waiting at balance of sender. So in this case, if we just wrote balance of sender is greater than or equal to amount without the asterisk, that would be an inconsistent comparison because you can't compare a channel with an amount. So in any case where you see the asterisk, we're evaluating the actual channel.
Yeah, so I just want to amplify what Joe was saying a little bit. This is yeah, sorry. There, whenever you communicate in the row calculus, even though the send sends a process and all values are processes, what the receiver receives is a quoted form of that thing. So it's the code of the thing rather than the thing itself. And there are many uses of that. Principal among them is metaprogramming. So you can think of the code as, or the quoted form as something that allows you, it's like the syntax tree of the thing, which would allow you to modify it. However, if you want to get from the code back to the value, the star unquotes it or evaluates it. And I want to distinguish that from accessing something at a channel, right? Now, and that's sort of when you place something at a channel, you retrieve it with a for, but there's an extra step because the thing that you retrieve is sorry, just looking at my navigation thing here. The thing that you retrieve is is always the quoted form, and so then you have to unquote it or evaluate it to get the value that you sent. So
Sorry, Greg, you just dropped out.
Kent, I'd say continue on in the meantime.
Yeah, okay. So, yeah, just, I mean, if you treat whenever exactly as Joe mentioned, this is a value, it kind of just makes sense. It's a value to value comparison. And so yeah, here we just have, we're decrementing the amount from the sender, and then we're increasing the amount to the receiver. And that's kind of just how you would expect a send to happen. And then on the case that one of the assertions did not was false, then we have to reinsert the previous balance or whatever we consumed out of these two channels. This is because this consume actually takes out the value, and so we have to place it back in. And this is tricky because we can't exactly do persistent or sort of like a traditional database read either, because then when we send out the value, we'll be placing two values onto the same location, so to speak. But it's sort of like a trade-off in the language design, should I say? And yeah, that's the transfer function. The transfer from function is really similar to the transfer function. The difference is the from does not have to be the message sender. And what this means is that the person who owns the address at from, or the channel, needs to give permission to the message sender to be able to send their tokens to some other channel. And this is done through the allowed map. And this is actually a map to a map, because allowed from is like all the addresses, or just simply all the addresses that you're sending from, and then the second map is sort of who they're giving permission to. And so we got the same sort of checks as before, and again we have the same balance from and then balance to, and then the allowed, we have to decrement the amounts, saying this sender is now only allowed to send a certain amount minus however much they already sent in the current transfer. And so that's, and again we have the same kind of restoring the previous state in case some condition failed. And so then approve is sort of just the way this is the setter for the allowed. That's a way of thinking about it. And allowance is just a getter for the allowed. And finally, you can just query the contract owner. Who I realized, that works, yeah. And I think, Joe, you had a comment about the race condition here between balances and balances owner.
I did, yeah. I wrote it in the Google Doc.
Yeah, I guess we don't have to discuss it too much in detail here.
No, but I think we should definitely talk about. Let's talk about the array convention that we adopted. We can start with an input term. So if you want to find, let's say, a nested.
I guess this one works here.
Right. Yeah. Okay. So essentially, we can. So obviously, we're treating everything as a channel. So we can go ahead and imagine then that just imagine an array is a large channel. And that each address in the array corresponds to yet another channel. So when we listen on balances of from, in this we have 4 balance of sender coming in on balances from. What we're doing is we're checking the essentially array, or actually it's a map in this case, for another channel, which is from. So we imagine balances as our first key, and then from as a second key. So when we go into the second key from, that's actually going to be the one that we're querying from. So go into balances, then go into from, and then search from for the balance of the sender. And this is actually really convenient because it allows us to kind of use data structures, and at least in the beginning, arrays and maps as just nested channels. We, however, have a trade-off here, and it's something to note, and that other programmers will likely notice as well. It's that, and Greg's been using the term referential transparency fairly consistently to discuss this or address this. And that's typically in other programming languages, when I write balances from, just imagine that that's an array, it evaluates balances from and automatically returns the result. In this case, however, we're looking for the result of this query on the left. So, so some people might be tempted and might originally think that if I just write balances from on the right and balances of sender on the left, then what I'll evaluate to is balance of sender comes in on balance of sender. And that's, that's a totally normal way to do it. And in fact, we would expect that people use that convention as well. Just because that's how people have been trained essentially for the history of modern programming. So what we've had to adopt is the double exclamation point convention. And the double exclamation point convention says, don't write necessarily to the value here. Don't evaluate this, but just go into balances and go into the from subchannel and write to the location of that subchannel. And this is kind of how we're counteracting the temptation to go ahead and read input statements as if the array index has already been evaluated and our result is sitting there. So in the case that we only have a, yeah, I think that's fair. So,
yeah.
So I think that's, can you guys hear me?
Yeah. I hear you, Greg.
So I cool. I appreciate that way of explaining it. I think I would add to that, on when you're on an input statement, you can't tell the difference between the sort of the nested channel interpretation and the go here and evaluate this expression, get the value, and when that value turns into a channel, then you can read from it. So that they're indistinguishable. But when you do the output as when you attempt to interpret output as assignment, you absolutely can. And in all modern programming languages, the left-hand side of an assignment is a kind of special creature, right? L values are sort of special creatures, you know, it's never treated as evaluate the expression on the left and then put something into the location there. It's always put something into the location that's sort of intuitively indicated by the expression. For example, you know, assign into this location in an array, right? You don't evaluate the index into the array and then attempt to assign to whatever the result is. You want to put the thing into the location in the array. That's the sort of the standard meaning of that kind of thing. And the double exclamation point is recovers that, because we want to be able to, on the with the single exclamation point, to have that kind of meaning where you can have a complicated expression, a complicated row-lang expression, and that turns into a channel, right? When you reduce it all down, you reduce it, eventually it reduces to a channel, and that you can do a send on. Whereas the double exclamation mark says, hey, don't evaluate this, treat it as if it were a location, aka a channel.
Right. So what we're actually recovering from, and the reason that this notation arises, is actually an asymmetry in how programmers are typically using arrays, assignments versus evaluating locations. So this was kind of an inherent. It's something that was going to come up anyway.
Yeah, that's exactly right. And there were other language features that we introduced. Again, these are all syntactic sugar, but we introduced them to make the code compact and readable. One thing that Joe has been arguing for a while, and I've been resisting until the last possible moment, is a recursive process definition form that wasn't contract. In other words, it's volatile. So when you enter into that process, if you shoot the when you begin evaluating a process that is defined, then if you shoot the machine in the head that was doing that, then you will lose that state because it's not stored on the blockchain. So that's something that we were kind of arguing about or discussing, and finally I just said, okay, well, it looks like there's enough pressure, there's enough sort of community desire to have this feature, so we've added that to the language. The trade-off, of course, is that then the Mercury release will have to support that language feature, and so we've kind of all decided to roll up our sleeves and support the language feature. So just want to make people aware of that fact, and that comes with additional notation, right? So Kent, do you have an example where we do the we do the dot, sort of contract instance dot, and then method name, or proc name.
Get it up for you. So if we had a contract, for example, C, and it took some arbitrary number of parameters, and we wanted to actually create an instance of C, and then we sort of, through the for expression, we get the instance of the C on the lowercase c, and now we want to call, I guess, something that we defined as sort of like a pseudo method. Then we can just do the C dot, the method name, and then pass through the argument, and we can use this as, I guess what the new def construct does.
But remember, it wouldn't be c.def, right? So inside C, you'd have a def. I see which form you're trying to do. You know what? We'll write up some examples and post them to the community so they can.
Okay.
Yeah. So that's but I think it adds a sort of nice halfway house. So what the tightrope that we've been walking along is attempting to keep the language as process centric as possible, knowing that on the one hand there's considerable community sort of training and pressure and sociology around functional and function-like languages. So if we go too far in terms of supporting applicative syntax, people will just glom onto that, and they'll do everything in that style, and they'll lose a lot of and they'll push the language faster and faster towards a functional language, which has the potential to lose all of the benefits that we're attempting to give. So that's why we're sort of we're having to balance on helping people with an existing convention, sort of by adopting as much of the existing convention as is reasonable, without tipping the language design into an older style, which is then going to cause people to, like water flowing downhill, sort of use cognitive patterns with which they're familiar. So that's something that we've been that's been a part of the methodology. I also want to say I am just so happy with the development discourse. It is such a delight. We have Alex from CoinFund, who's really driving the process. He's really quite diligent. He doesn't, like, if there's any moment where he doesn't understand anything or he feels there's a question, he is not afraid to dig in, and this has been raising the quality bar tremendously. Really happy about that. Also really happy for like Kent keeps saying, wait a minute, if we go down this path, the contract is going to be twice as long as the Solidity contract. Let's not do that, right? And that's been really good, because Kent is right and his impulse is right. If we don't have something that's sort of in the ballpark of expressiveness of modern languages, then people will simply ignore us. I think the evidence is in front of us that clearly we do. The DAO contract example was very much sort of in the same ballpark of expressiveness as the Solidity contract. This was the one where we showed that our type system would have caught the bug. And now when we're going through and doing a side-by-side comparison of implementation of ERC20 like behavior, and again we're starting to see that it's roughly the same kind of expressiveness. But there are new kinds of opportunities, right? Solidity offers no meta-programming capabilities, none, right? Whereas Rolang is all about meta-programming capabilities. So you can write programs that write programs. It's a part of the language. Likewise, Solidity does not currently have any concurrency features. nor does Solidity have the kinds of behavioral typing capabilities that we have. And so all of this is, I believe, just the tip of the iceberg. So we can do, and this is kind of what's necessary for innovation. You have to be able to do the simple problems with the same level of ease and facility. And I believe that that's what we're demonstrating now, that we can do the basic stuff. Hello world in this domain is being able to write tokens and wallets, right? That in some sense, I mean, this is no disparagement, but in some sense, that's what Ethereum, that's the flagship Ethereum application, right? What Ethereum is really good for is writing applications which are essentially variations on tokens and wallets. So we can do that, and we can do that with the same sort of ease of expression. But what we will see in the upcoming weeks is that we can do a lot more, a whole lot more. And so kind of a part of that, I think it would be really, really useful to talk about some of the stuff that Mike and I have been working on with Ladle. I'll just give a quick update on that. Last week, Mike and I submitted 2 papers. One was to Express SOS. So this is an expressiveness and concurrency conference. So again, this whole topic of having a framework that is expressive is the name of the game, so to speak. And what that was an update of the row combinators paper. And I have placed the updated version that we submitted on archive, and I put the link to the updated version in the process calculi channel in Slack, so people can see that. And then the other paper we submitted, Mike did a really nice sort of more conversational write-up of the Ladle algorithm itself. It turns out that they extended the deadline, so we're going to take advantage of the extension to do some rewrites on the paper, add some more material, and flesh out some of the argumentation there. There is a draft that people can see. Is there, Mike?
I haven't yet uploaded it to the archive.
Okay, cool.
But it's on your Pi4U, so they can see it on the Lighthouse Pi4U GitHub repo.
That's correct. If anyone wants to see some of the work or the intermediate stages in the work, that's all on the Pi4U repo under Lighthouse. That's LEITHAUS.
And the particular papers are Memo 2017 and what was the RoComb?
Yeah, exactly. So Mike, so we've been having some really interesting conversations over the last few days. Do you want to see if you can give a summary of some of that?
Sorry, of which part? There's
Well,
all kinds of interesting stuff that we've been talking about, but
yeah, I mean, yeah. I mean, in particular, I think the whole 2 context discussion is interesting. I also think that I was really mildly surprised to hear myself interpret the monad laws as giving us subtyping relations. So honestly, you were asking me about them, and I said, "Oh, well, obviously." But I think maybe if we could kind of summarize some of those concerns and why they're relevant for other folks. You're always pretty good at that kind of thing. I hate to put you on the spot.
Oh, not a problem. So the idea is that we start with a model of a term calculus. And for us, a term calculus has a set of sorts, which says what kind of structures there are in the state of the computer. For a very simple language like lambda calculus, there's just one. It's a lambda term. If you get to a very complicated language like C, there are hundreds of them. For row calculus, we have names and processes as our two sorts. There are term constructors that take multiple copies of sorts, data of a particular sort, and put it together to form a new term or a new instance of some other sort. So, for example, in lambda calculus, you've got application that takes two terms and applies them together to get a new term, or an abstraction that takes a name and a term, says lambda x dot t, and produces a new term. So those are how we build up the state. Then there are equations between compositions of term constructors that say what kind of things we want to ignore. So for example, in lambda calculus, we want to ignore differences in the dummy variables. So if I say f of x equals x squared, or if I say f of y equals y squared, they're the same function. We don't care what we use for x and y. So differences in the bound variables. In pi calculus and row calculus, we don't care in what order we put processes in parallel with each other. A par b is the same as b par a. So those equations capture what we mean by structural congruence. And then the fourth part is a set of reduction rules. And because of the categorical nature of things, these reduction rules have to hold in every context. So I was lying a little bit when I said that the morphisms are term constructors, because we also have context constructors that say anything inside of this context can be reduced. Whereas we may not always want it to. For example, in all modern programming languages, if I say, or in JavaScript, for instance, function x, return x squared. Even if there's a reduction that can happen in the body of the function, the body does not have a reduction once you put it underneath the function keyword. So it has to wait until it gets a value, and then it can evaluate it. So that's called weak head normal form. Happens in Haskell as well. But if there's a reduction from t to t prime, we don't want a reduction from lambda x dot t to lambda x dot t prime. So we can't have these reductions happening in any context. We need to mark the contexts in which they're allowed to happen. So that's the fifth piece of the puzzle. And so by putting all of these 5 things together, we get what in category theory terminology is called a graph-enriched Levere theory. And so then we can take models of that in the category of graphs and graph homomorphisms. And what that means is that we get a graph where the nodes are terms in the calculus, that is states of the computation, and the edges are rewrites in the term calculus, that is state transitions, how we get from the computer being in one state to the next one, to updating the program counter, popping things on and off the stack. All of those sorts of operations are these rewrites. And so the graph tells us, if we're here now, where can we get to and where have we come from? So all of our reasoning after this point is about this graph of states and transitions. So then we come up with, we look at the edges in the graph. And the particular kind of graph we're using allows multiple edges between nodes. All the edges are directed, and each vertex comes with a chosen self loop. So we can talk about subgraphs of this thing only by looking at sets of edges. So then to talk about subsets of the set of all edges, we use the theory of a hiding algebra, or in other words, we look at subsets of these edges. And that gives us a category of subsets of edges, subgraphs, graph homomorphisms between those. And it's also enriched over graph, which means that we have graph transformations. So you can take a subgraph and shift all of the vertices over to another subgraph. Each one is connected by a single edge. So it's talking about transitions that apply to an entire class of states. In order to get a typed calculus, first we look at just the one whole term contexts. So the things that say, you give me a term, I wrap it in some extra stuff and give you back a term. When we do this for lambda calculus, these become the morphisms in a Cartesian closed category. When we do this for pi calculus, we get some other kind of categorical structure that we haven't worked out all the details of in order to give it the name that anyone else would recognize. But we know how to derive all of this structure. In order to do subtyping, we take the operations from the collection monad. So when we say collection, what we mean is a monad whose algebras are monoids. That is, using Haskell language, they're an M plus. I'm sorry, they're monad plus that have two operations, M plus and M0. A monoid, for those who aren't familiar with it, is a structure that has an associative binary multiplication and an identity element. So if you think of string concatenation, that's an example. In fact, it's the free monoid on a set. So in our collections, we can do sets because union gives us an underlying monoid. But we can also do lists and trees and so forth. All of those have monoids underlying them. So we take the monoid structure, and in the case of set, that's empty set is the identity and union is the monoid operation. So empty set is a subtype of anything. We have a one whole collection context as being a typing rule. So if I just take the identity context, I know that empty set is a subtype of that. I can also say the one whole context that takes the union with some other type. And so then I know that the identity context is a subtype of the whole or A, the whole union A. And so those two operations give me a set of subtyping. And then we can prove specific things about the collection we've chosen. So for example, when we've got hiding algebras, we also know that top is a supertype of everything. We also have implication types, and those are neither subtypes nor supertypes of certain things. Anyway, those are special cases, and we have to reason about them independently. But for every collection that we've got, we have those two typing rules. Then we want to introduce modalities, which mean, is this behavior eventually possible? Let me do a little screen share here. Can you see this?
Yes, I can see it.
Okay, great. So here is a modality with two parameters, and I'm using angle brackets to recall the diamond possibility modality that's fairly standard in logic. And in this case, we're parameterizing it with two types and two contexts. So this says that for every term, and top here means every term that's possible, we want those t such that there exists a u, such that when we put it in the first context with t, that there's a reduction to this other value v, and the v has this other type we want. Now, this is kind of hard to read, but in the case of where C is application, this thing becomes the arrow modality. That is, if there is, we want those terms for which when I apply it to an X, I get a Y. D in this case is the identity context. So when I apply T to U, I get a V, which is of type Y. So the arrow type that's so familiar from all applicative calculi falls out as a special case of this. Now, in lambda calculus and SK combinators, which are something that Haskell Curry invented to make thinking about them, reasoning about them easier, possibility is the same as necessity. It's a confluent programming language. Doesn't matter what part you reduce first. But if you don't make that assumption, then there are these 4 different possible modalities where this one says, if I combine T and U in this context, then it's possible to reduce to something with V. This one says, no matter what U I choose, there's a way to get to V, which is a much stronger property. This one says that for some U, all of the rewrites go to V. So if I choose some other U, they may go to some other type entirely. But for this U, all of them reduce to something in D of Y. And this is the strictest that says any U I choose and any rewrite out of that system, they all end up in Y. Mm-hmm. So these let us distinguish far more finely behaviors in calculi like pi calculus.
So I mean, so one of the upshots of this is that, so on the one hand, we unify both the possibility operator and the necessity operator in the logics for the pi calculus with the arrow, and on the other hand, we disambiguate 4 different kinds of modalities, only 2 of which I have seen as actually studied extensively in the literature.
And there are also, I mean, all of these things are single step rewrites. There's also the arbitrary number of step rewrites, which become undecidable. Yeah.
Right.
In many circumstances.
Yeah.
The other stuff here, so if I have a situation where U is of type A and a rewrite from T applied to U to some term V of type B, then I can derive that T is of type A arrow B. So this gives us an inference rule for our logic.
Yeah. So essentially, you know, what this comes down to is before we had been looking at model theoretic ways of doing the calculation for the typing for Rolang. This gives us not only allows us to do the proof theory and to show that the proof theory and the model theory coincide, but it gives us a proof theoretic type check, which in many respects will be easier to write down, but also faster. So we're very excited about that as well. But again, in the larger framework, you can imagine taking something like K framework. You write down whatever your term rewrite system is, whether it's, you know, Rolang or JavaScript or Solidity or C#, whatever it is, and you provide it with a notion of collection, like, you know, I want to collect all the results in sets, or I want to collect them in trees, or whatever it is, and then you press a button.
Oh, you also need the distributive law.
And you need the distributive law, exactly. You provide those 3 inputs. You press a button, and out pops a type system for your language, which is guaranteed to be sound and complete. Now let's compare this to modern practice, right? So there's still many, many languages which don't have type systems and which have cost the industry enormously in terms of both maintenance, bug, and also future proofing, right? And as an example, JavaScript, the three of the major vendors, right? So that would be Google, Microsoft, and Facebook have all produced typed versions of JavaScript because the lack of typing prevents it from being the kind of thing that you could have industrial scale code bases on. So already the value here is tremendous just for those existing languages, but it also allows you to calculate sound and complete languages, type systems for new languages like Rolang. And if you think about that, like Scala had to go all the way back to the drawing board for soundness and completeness of their type system because they were running into soundness issues, right? And Scala is certainly being used in commercial and industrial scale code bases, right? So the fact that those code bases are relying on type systems which are known to be unsound in certain cases is kind of a big deal. Especially if we want to be able to rely upon these kinds of methodologies to produce code that is solid enough, robust enough to carry the world's financial infrastructure on its back. So that gives us kind of the context and the sort of set of practices for why this work is important. So again, the platform with Ladle and with the kind of generic consensus algorithms that Vlad has been considering, you could imagine a souped up version of K-framework where you press a button and all of those features are for free. They're just, they're automatically handed to you. And so now we move into this new world where, we're not having to do all of this labor by hand, which literally, hundreds of thousands, if not millions of programmers are all carrying on their backs, right? That part goes away and we get to focus on the application stuff. Now with respect to the application stuff, one of the things that Vlad said to us, rather pointedly, is he said, I know that Greg has talked about these kinds of things in the past, especially when he was with Scenario, but the RChain message doesn't reflect some of the social values that you've talked about in the past. And we've heard this also from others. We had a nice call with an Italian investor yesterday who was asking us to be much more explicit about those kinds of messages. And so I took the time to go ahead and begin writing up some of that. And I pasted a link to a write-up that came from a reply to this Italian investor. And so people, I would strongly encourage people to check that out. I put the link in the chat and make some comments about that. I would love to read it out loud, but I want to give Ed a chance to give some updates about some of the other things that have happened with holdings. I know we're running really close to, we're well over time, but.
Hey everyone, how are you doing? Hi, Greg.
Hey.
Yeah, so I don't know what was covered in the first half. I joined about a half hour ago. Was talking to an advisor who's well known in the industry, and I talked to several different people yesterday, and so it's great to hear the interest. Everyone acknowledges the scalability and trustworthiness and other kinds of value propositions that RChain brings to the table, but they have a whole host of different ideas about how we address them and how we best accelerate our traction, both in terms of the investment raising, as well as our go-to-market strategy. So it's great to hear, and the other conversations that both Greg and I are getting a lot of are investors coming to us and say, how do we participate? And we don't have all the answers they want to hear is like simply do X. The holding company is raising a SAFE, which is a simple agreement for future equity. We closed one investment there. We have some additional. Contact me if you have questions. And then we are talking about a private token placement, and I won't describe the specifics. Greg is sort of the center of that discussion, but that will change to another individual, I believe, in the coming weeks. And then, like I say, just people coming to us with different sets of interests there. So anyway, a lot of great conversations this past week. We've on the holding side, have done additional work on the UX development. This is sort of an extension of the Lively Gig work. Actually, it's being done on a Lively Gig specifically, and then also Glenn is continuing to research and plan some roadmap possibilities around identity. I know he participated in the Jim's and the community's identity meeting on Saturday morning. So that's in a whirlwind. That's kind of an update. Yeah, still there.
Ed, thank you very much for that. I was muted and I was talking away, and of course muted. No, I just wanted to say, did you mention that we closed a safe?
I did in passing. We closed one investor on the safe.
Yeah, I think this is very, very important step, and we really need to acknowledge that. So congratulations to everyone.
So, can you give us any more details on who the investor is or how much the safe?
I don't want to at this time. We have.
Yeah, we're not. They've asked to remain anonymous. But we can talk to you privately.
No worries.
Thanks, Mike.
Yeah, and the one thing that I want to say about the process is I have been so excited and heartened by the level of diligence that everyone is bringing to the table. You know, people are really engaged. They really want to know, you know, how all the pieces fit together. And this just raises the game, and it's just a delight to work with people who are that attentive and that careful, and it just makes our offering that much better. So it's been a really very rewarding process.
Yeah, absolutely. And in addition to investors approaching us now, how can we help financially? We also have advisors coming to us to say, we want to be involved in this conversation. We want to. How they ask, after I do a pitch, how can I help? And often that's connect me to startups that will want to build on RChain that realize they can't realize their vision on Ethereum, for example, or other blockchains. So it's great to get those conversations ramped up.
Absolutely. I mean, I don't feel like the meeting needs to end when I jump off, but before I go, I'm gonna, just take the opportunity to read out loud what I wrote to this Italian investor who basically I closed the call theirs by saying, well, look, this is really about creating an alternative coordination technology that will enable us to move at the a responsive pace with respect to climate change. And he really wanted to hear more about that. He wanted me to be more explicit about that. So this is the response I wrote. I said, really, it is very simple to say, the proper role of capital is to help make it easier to take care of each other and the planet. And just for emphasis, I want to repeat that here. This goes out to Vlad and and all those people who've asked me to sort of reiterate and reaffirm this. The proper role of capital is to help make it easier to take care of each other and the planet. If it isn't serving this purpose, it is because we are using it unwisely. This is what I mean when I say that capital is a coordination tool. Yes, it allows us to coordinate our activities, but that coordination is in order to take care of each other and the planet in which we live. Likewise, capital is linked to other coordination tools. Governance is inextricably linked to capital. So we've learned the wisdom of the collective, right? We've recognized that both in the US Constitution and in much scientific literature. But so we've learned the wisdom of the collective, the cornerstone of democracy, and we are poised to realize that self-governance is built on the wisdom of the collective. Each collective, each self is a collective. You know, we're still wrapping our heads around this idea, but in fact, it's true. Each self is a collective. And when the collectives are actually wise, then they are living centers. When we freely self-organize and coordinate within these principles, we are able to build living structures that are more likely to take care of each other and our gracious planet Earth. Currently, however, the coordination tools we have, especially the current centrally controlled forms of capital and the existing governance structures, are not being used in a manner that is moving fast enough or effectively enough to meet the oncoming consequences of human-caused climate change. Nowhere is this more evident than at the federal level of the current US government. Many of us, from the sciences and the arts, from the state government of California to the C-level leadership of companies like Overstock, have come to believe that these structures simply cannot be fixed from within, and we must build real alternatives side by side the existing structures if we want to protect the delicate ecosystem maintaining the precious life on this planet from catastrophic failure. When these structures are far enough along, or when we are far enough along with these alternative structures, we can help as many people as possible transition to the new, more viable structures. So this is what RChain is doing. We are building a scalable alternative means of coordination that will enable us to move many times more rapidly and more effectively. So the impact of the blockchain technology on clearing and settlement alone should provide evidence for this. Right now, the clearing and settlements pipeline is deep enough and long enough that companies like Amazon can build their empires on it, and it can completely destroy and obliterate small businesses, right? And the blockchain totally revamps that, right? So just that alone should begin to be evidence of the kind of scope and of the change we're talking about. But if people want to understand the real import of the DAO, or if they do understand the real import of the DAO, they will begin to see more of the scope of the change. So when I first looked at Kickstarter, I said to myself, why can't US congressional funding be run this way? Of course, one of the problems is that Kickstarter is a centralized service, so there would be trust issues around that. With blockchain technology, you can have public funding of public works in a completely decentralized manner, without a centralized trust broker, and at a completely different scale. So among the scales that we're talking about here are the temporal ones. So among the major changes in scale is the concomitant temporal agility. So the ability to turn on a dime, more specifically, the ability to change course based on near real-time feedback of the impact of actions taken will be vastly superior in this new kind of setup. So that's when human society has the potential to enter into a much more real-time engagement with life on our gracious planet Earth. And from my perspective, this is a necessary step for our survival, as well as our evolution and our awakening to our real potential. So I'll drop the mic here and shut up. Kent, I'll see you guys at the Airbnb in a little bit.
Cool. What time are we meeting?
We said 1, right? Alex wanted to wait until 1. We were going to meet at 12, but he asked for 1.
Got it. See you then.
All right. Ciao.